Hey, how's it going? Back at it like a bad habit. My name is Abhinav Srivastava, and in today's video, we are going to be finding out what a data structure is. And one of the reasons why I wanted to dedicate one video to this, even though you might already know what a data structure is because a lot of colleges, especially like where I study in India, in my college, what they do is they do a 4 credit course on data structures and algorithms, in which they include algorithms, uh, all the algorithm complexities, algorithm analysis, and stuff like that. How to write good algorithms, design practices, all the while also focusing on data structures. And you cannot do this in like 2 hours a week for 4 months with like three classes uh, in a week. I mean, what is that like? 6 hours a week. You can't do that for 4 months. You cannot cover the basics of data structure and the advanced forms of data structure, the basic of algorithms and the advanced forms of algorithm. You cannot do that in 4 months. So I wanted to talk about what data structure is so that you know and what a data structure is, and if anyone asks you, you are confident in answering what a data structure is in technical terms. Fucking love coffee, dude. Anyway, I made a quick little slide to help you out with everything, and I'm referring to another website. I don't remember the name. I'll put the acknowledgements in the description below. So let's get started with this. How do I slide? And I'll give you these slides, but it's of no use really. Where view present, yeah, there we go. All right, F11. It's not. Okay, so welcome to DS 101, episode 1. What is a data structure? A data structure is just a way to define how you're going to store data in the memory, and that's it. And how we do that is by basically defining functions and classes and stuff like that. We use all of that to make more, rigid data structures. So there are a lot of types of data structures. You've got built-in data structures and user-defined data structures. So in built-in, you've got integer, float, character, and pointers. And in user-defined, you've got arrays, lists, and files. Now, files are also a type of data structures, but we will not be talking about any of this, okay? In lists, you've got, from lists, you make linear lists, and there are non-linear lists, then there are stacks and queues, and then there are trees and graphs, okay? So there are something known as primitive data types. Now that depends on what language you're using. Your primitive data types are defined. But as far as C++ is concerned, I think these will be your primitive data types plus minus lists and files. Like they might or might not be there. In linear data types, you've got data items that are arranged in a linear sequence, like an array. A set from Python is not a linear data type because there's no ordering of data types. There's no indexing of data types, so to say. A non-linear is just not in sequence, like trees or graphs, right? Trees are not in sequence, graphs are not in sequence. I mean, if you have a directional graph, then probably it is in sequence, but who knows? Like, it's not in sequence, it's just directed. We'll get to the differences later on. I don't want to complicate this at all. Then there's homogeneous. All elements are of the same type, which is kind of like arrays. I mean, if you have a string array, all of the arrays are basically of this. All of the elements of the array are of the same type. So let's say you have an integer array. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of them are of the same type. Non-homogeneous vis-a-vis. You've got integers, strings, everything in between. Okay. Static data structures are data structures whose memory is already allocated at the top. Okay. Now, in one second before I get to that point, let me get to dynamic. Dynamic is basically vis-a-vis of what static was. Like linked lists with pointers. We'll get to what all of this means. Don't get too bogged down with static and dynamic. If you have done Python before, in Python you don't have to declare the size of your array at starting of the code, and that's because Python uses pointers. I guess I'm not 100% sure, but Python basically uses pointers for every kind of data structure, right? So even if you are declaring an array, you don't have to declare the size of the array. It's because Python already just goes with a dynamic data structure for everything. Okay, but if you're using C++, you have to define it from the start. So in C++, a static data type would be an array, but in Python it would not be static. Dynamic data type is again just suppose you're making a linked list, which is basically a list of boxes, list of linked boxes, so to say. Then you basically use pointers, and then you can allocate more memory as you run out of memory, and that is linked list with pointers. So that's all for this video. In this video we talked about what a data structure is, which is basically a way to define how you're going to store data into the memory of the computer. We talked about different data structures and different types of data structures, and we talked about linear, non-linear, homogeneous, non-homogeneous, static, and dynamic type data structures. That's all for this video. Let me catch you in episode 2 of DS 101, and let's get started with the actual coding stuff. I'm really fucking excited for that.